To talk about pH, pH is defined as negative logarithm base 10, and it's written as log rather than logarithm, of concentration of hydrogen. It's simply a mathematical scale, and when first time it was used in German language, it was defined as power of hydrogen, which is exponential power, meaning that a concentration of hydrogens, usually for sake of calculations, we have 1 mole per decimeter cube as maximum concentration, and then it gets diluted. So let's say you take 1 and dilute it by 10-fold, so it's 10 to minus 1, and if you dilute it by 100 times, 10 to minus 2. Now log is nothing but your exponent, and since all these numbers are negative, in order to have positive number, we have a negative log. So for example, if your concentration is 0.1, your pH is simply 1. If concentration is 0.01, which is 10 raised to negative 2, pH is 2. If concentration is 1, it's 10 raised to power 0. Anything raised to power 0 is equal to 1. Therefore, pH is 0. And this is considered to be strongest acid. 10 to minus 3 and 10 to minus 4, you see accordingly. Then this friendly scale comes to life. pH and the scale is going from 0 to 14. Now, if pH is less than 7, we consider that solution to be acidic. If pH is greater than 7, we consider that solution to be basic. Now, this scale only works at room temperature. So this is at 25 degrees Celsius. If you change the temperature, your scale will change. Now, why do we use pH? Because concentrations are a bit annoying. In order to not to talk about 10 to minus 14 mole per decimeter cube solution of, let's say, hydrochloric acid, we talk about a solution that has pH of 14. And then everybody knows, whether you're a chemist or not, that this is a strong base or a basic solution. So pH is simply a new mathematical scale, and it's negative log. One other related information is, if you have pH and you want to find out concentration of hydrogen, you can take inverse log in calculator, or just remember this time is 10 raised to negative pH. So two related equations. Now on the next slide, I want to talk about one other sort of very important and fine point, to realize that every time you change the pH by increment of 1, you rather change the concentration of hydrogen by 10-fold. So what I want you to remember is pH is a logarithmic scale. Therefore, a change of unit of pH, just 1 pH, corresponds to 10-fold concentration. What do I mean? In order to make it simpler, let's just compare one example. What about pH equals 2 of a solution versus pH equals 6? Which solution is more dilute? Which one is more concentrated? So what I'm going to do is have a portion of my pH scale, and let's say this is pH equals 2. Next increment, pH of 3, 4, 5, and 6, and I stop. So what I said, if it's log, that means the difference between 2 and 3 is 10-fold. So this is simply a 10. The difference between 3 and 4 is another 10. So multiply by 10. Another increment of 10. Another increment of 10. This is 10 times 10 times 10 times 10, which is 10,000 times. So you can say pH equal 2 is 10,000 times more concentrated than solution of pH equals 6. So hopefully you remember this fine point, that increments of pH corresponds to 10-fold increments of concentration of hydrogens.